Hello everyone. So welcome again to my another video on AWS Certified Solution Architect Associate exam. Okay, so again in this video we'll go through few question and answer with explanation, and we'll go through the options which are correct and which are incorrect, and we'll also see why the other options are incorrect, and we'll explain it. Okay, so now let's start with question 1. So the question 1 says, a company has an application that is running on Amazon EC2 instances. A solutions architect has standardized the company on a particular instance family and various instance sizes based on the current needs of the company. The company wants to maximize cost savings for the application over the next 3 years. The company needs to be able to change the instance family and sizes in the next 6 months based on application popularity and usage. So which solution will meet these requirements most effectively? So option 1 is compute savings plan, EC2 instance savings plan, zonal reserved instances, standard reserved instances. So let us see which one is the correct. So now let us see the scenario recap. Okay, so you are running application on Amazon EC2 instances that we have already seen the question. You are standardized to one instance family for now, but that could change within 6 months. Okay, you want to maximize cost saving for 3 years. You need flexibility to change instance family and size later. Alright, so in this one the compute savings plan is the best choice. Why it is best choice? Let's see. So it covers any EC2 instance regardless of family, size, region, OS, tenancy, and even AWS Fargate or Lambda. Okay, and its term is 1 or 3 years. You choose 3 for maximum savings. Okay, and it has flexibility. You can change families or size anytime without losing the discount, and it has savings up to 66% over on demand. Okay, so it is perfect match. So you get long-term savings and the ability to switch instances families in 6 months. Okay, now see why other options are incorrect. So option 2 says EC2 instance savings plan. So it covers one specific instance family per region. For instance, M5 in US East 1 region. Okay, in flexibility you can change size M5 large to M5X large, OS or tenancy, but not the family M5 to C6G. Okay, so it is not as flexible as compute savings plan. So problem, you said you may change the instance family soon. That would break the benefit. You can see here. So not suitable. It locks you into a family. Okay, option 3, zonal reserved instance. That is RIs. Okay, so we can see it covers specific availability zone plus instance type, that is M5 large in US East A1A region. Okay, and benefits, capacity reservation and some savings are there. So it don't have any flexibility. You are tied to instance type, family and AZ. So what is the problem? If you change family or move AZ, you will lose the reservation. So not suitable, it's too rigid. So option 4, standard reserved instances. So in this one, so it only covers a specific instance family, region, OS and tenancy. Flexibility, you can change sizes within the family size using instance size flexibility, but not the family itself. And its convertible RIs would allow family changes, but they are not listed here, and even those are less flexible and more complex than savings plan. So it is not suitable as well. It locks family, not future proof for your case. Okay, So what is the conclusion? You can see in the table. Compute saving plan has the highest flexibility. Its savings are to 66%. EC2 instance savings plan slightly higher. However, you can't change the family. That was your requirement. So savings plan, actually the compute savings plan would be the best choice. Okay. So the final answer will be compute savings plans because it maximizes savings while allowing complete flexibility to change instance, families and sizes over time. Okay. Okay. Now let's move to question 2. So the question 2 says, a company is moving its data management application to AWS. The company wants to transition to an event-driven architecture. The architecture needs to be more distributed and to use serverless concepts while performing the different aspects of the workflow. The company also wants to minimize operational overhead. So which solution will meet this requirement? So option 1 says, build out the workflow in AWS Glue. Use AWS Glue to invoke AWS Lambda function to process the workflow steps. Build out the workflow in AWS step functions. This is option 2 actually. Deploy the application on Amazon EC2 instances. Use step functions to invoke the workflow steps on the EC2 instances. And number 3 is build out the workflow in Amazon EventBridge. Use EventBridge to invoke AWS Lambda function on a schedule to process the workflow steps. And option 4 says build out the workflow in AWS step functions. Use step functions to create a state machine. Use the state machine to invoke AWS Lambda functions to process the workflow steps. Okay. So let's take the explanation. What is the requirement? You have to move data. You have to move data management apps to AWS. Okay. And transition to an event-driven architecture. This is the transition here. Architecture should be more distributed. Use serverless concepts. Okay, that we have seen in the question. And minimize operational overhead. So option 1, build out the workflow in AWS Glue. Use AWS Glue to invoke AWS Lambda function to process the workflow steps. So this is incorrect. So you can see here, actually Glue is primarily a data integration and ETL service tool. Actually, it is not a general purpose workflow or orchestration service. Okay. And you can invoke Lambda from Glue, but it's not designed for event-driven distributed application workflows. So it is operationally less flexible and more suited for data transformation tasks, not application orchestration. So option 2, build out the workflow in AWS step functions. Deploy the application on Amazon EC2 instances. Use step function to invoke the workflow steps on the EC2 instances. This is also incorrect. Why? This introduces operational overhead, that is EC2 provisioning, scaling and patching. And the question also says to minimize operational overhead and use serverless concepts. So EC2 will not be a good choice. As you know, EC2 is not serverless. Now see option 3. Build out the workflow in Amazon EventBridge. Use EventBridge to invoke AWS Lambda functions on a schedule to process the workflow steps. This is also incorrect. Actually, EventBridge is excellent for event routing, that is publishing, subscribing between services, but not for workflow orchestration. It cannot manage sequences, dependencies or state transitions between multiple steps. Using EventBridge on a schedule is not fully event driven in the intended scene. It's time driven actually. So option 4, it is the correct one. It says build out the workflow in AWS step function. Use step functions to create a state machine. and use the state machine to invoke AWS Lambda function to process the workflow steps. Okay, so AWS state function is a serverless orchestration service designed exactly for this use case. Okay, so it allows you to model workflows as state machines, with each step invoking serverless tasks like Lambda. And it's event driven, highly available, and requires minimal operational management. Each functions perform a discrete workflow steps, managing the distributed and serverless requirements perfectly. So the final answer is option 4. So build out the workflow in AWS step function, use step function to create a state machine, use the state machine to invoke AWS Lambda function to process the workflow steps. Okay, so I hope it is clear to you, and if you like the video, please subscribe my channel and share it with your friends so they can also benefit with it. So now let's move to question 3. So the question 3 says, a company is designing the network of an online multiplayer game. The game uses the UDP networking protocol and will be deployed in 8 AWS regions. The network architecture needs to minimize latency and packet loss to give end users a high quality gaming experience. So which solution will meet these requirements? So option 1 says, set up a transit gateway in each region, create inter-region peering attachments between each transit gateways. Option 2 says, set up AWS global accelerator with UDP listeners and endpoint groups in each region. Okay, set up Amazon CloudFront with UDP turned on, configure an origin in each region. Set up a VPC peering mesh between each region, turn on UDP for each VPC. Okay, so the correct answer is set up AWS global accelerator with UDP listeners and endpoint groups in each region. So let's see why this is correct. As you know that AWS global accelerator is specifically designed to optimize network performance across multiple AWS regions, minimize the latency and packet loss by routing user traffic through AWS global network backbone rather than unpredictable public internet. Okay, and it supports both UDP and TCP traffic. Fine, and it automatically routes the nearest healthy endpoint using anycast IP addresses. Fine, so you got the reason why this option is correct. So for an online multiplayer game where low latency and minimal packet loss are critical, global accelerator is the ideal choice. So why not the other options? Transit gateway in each region with inter-region peering. See, transit gateway are for VPC to VPC connectivity. Okay, not for global client traffic optimization. They are not optimized user to application latency or packet routing across the public internet. It also, transit gateway doesn't directly handle UDP game traffic from users on the internet. Okay, option 2, Amazon CloudFront with UDP turned on. No, this is also incorrect. CloudFront only supports HTTP, HTTPS, TCP traffic. UDP is not supported. It's for web content delivery, static and dynamic, not real-time, low latency gaming traffic. So this option is technically invalid. Okay. So number 3, VPC peering mesh between each region. VPC peering provides private connectivity between VPCs but doesn't provide optimized client to region latency. does not reduce packet loss, is not intended for public internet facing game traffic. Okay, so these are the reason the other three options are not suitable for this one. All right. And it also adds complex management overhead. Okay, so you can see the summary table here. AWS Global Accelerator, it supports UDP global optimization, and its purpose is the global traffic acceleration. So this is the correct one. So the final answer, set up AWS Global Accelerator with UDP listeners and endpoint group in each region. So I hope you like this video, and if you like it, please share it with your friends and subscribe it as well. Okay, so it gives me a kind of enthusiasm to create more videos. Okay, so your subscription matters to me, and it will also help to you. And I will bring on a few more videos on this topic, so that you can accelerate in your exam. Okay, I think you will not get such videos with the explanation. Okay, fine. So thank you for watching. Thank you very much. Bye bye.